Well, hello everybody. Welcome to my tech talk. My name is Stephen Batman, and today I wanted to talk to you a little bit about a program called Unity. And along with Unity, I'm going to go a little bit into game development and game engines as a whole. And so, first off, why I chose this topic was when I was a kid. I was just like many other people. I was very interested in video games. I played video games all the time. I was always buying the new one. And just every year, the graphics, the players, everything just seemed to magically improve. And these wizards behind the curtain were creating amazing products that I just couldn't get enough of. I did take a couple moments here and there to think, how is this done? But I thought genius is better than myself, must be behind it, and there must be some sort of magic solution that I am not aware of and something just beyond me. But given this tech talk, I was able to revisit this. And seeing as how recently in this boot camp, we've been doing a lot of demystifying of technical topics, so to speak, such as React and all these things. I thought it was appropriate to go into Unity. And I hope with this talk that those of you who might have felt like me, maybe you were interested in games, maybe you had heard the word game engine or Unity before, but you never really took the time to explore that any further. Maybe this can give you a nice basis to continue that curiosity. But before that, I want to do a brief history of game development, and I'm going to start with this right here. Now, this image might immediately bring up some memories or some knowledge for some of you, and for those of you that doesn't, this game is called Pong. Now, Pong is a very famous game in that it was one of the first commercially successful games ever sold basically anywhere in a home console. It was released by Atari in the early 70s, and as you can see, it's a fairly simple concept. Two people bounce a ball, and of course, it's a score, and all good fun. But what a lot of people don't know is that this game actually, unlike modern games, was not coded whatsoever. It was actually created with this lovely circuitry using gate chips, timers, counter chips, TTL circuits. Essentially, pure physical electronics were concocted and as you can see in that diagram, to create what we would consider today a very simple game. However, after that, things got a little bit more modernized in that they were actually programming video games and they started creating these huge page software that would just take up thousands and thousands of lines of code just to create simple video games. And even if you wanted to create another one, you'd have to redo the whole thing over again. Now, that led to, in the mid 1980s, many different 2D, what they call game creation systems were developed at that time. And because at the time also the modern term game engine was not introduced until the 1990s. However, in the 1980s, there were things such as, most notably, Nintendo's smooth side scrolling engine, which was developed by Shigeru Miyamoto's team for the game, the side scrolling racing game Excitebike, which maybe you do or do not know. But what you probably do know is that that same engine, so to speak, was used to create Super Mario Brothers, which I'm sure you do know. And not just Super Mario Brothers, but platformers as a genre was introduced. Now, the fact that this scrolling engine was introduced, any potential platforming game could just pick it up and have a side scrolling thing. And that actually, like I said, spawned a whole new genre. But now you can see how maybe the game developers are starting to think about sectioning off portions of core functionality in order to share it across different games and able to create different types of games. That's kind of the whole theory behind how game engines work. But once again, so the modern game engine as we know it really was not introduced until the mid 1990s, once Doom and Quake came out. And these games were, I don't know how, paramount to game engines and their rise in the gaming industry, because these first-person shooters had graphics and functionality that had never been seen before in video games. And developers all over wanted to create their own versions with their own ideas, concepts put in. That led to ID Software licensing core portions of the Doom and Quake software to other developers, which was the start of the third-party game engine industry. Now, it wasn't till a few years later with 1998's Epic Game 1998 Unreal and their subsequent Unreal Engine, where game engines really started to take a hold on game development as a whole. This game engine, Unreal Engine, which is very important to remember, it was for a while the #1 most dominating game until the release of Unity, actually. Now, Unity was launched in 2005, and today it is one of the most popular game engines in the world. And what Unity basically is, it's a cross-platform game engine used to develop 2D and 3D games, as well as other interactive experiences. So here's a nice little graphic I put together with a sample, I would say, of some of the game engines. As you can see, Unity, Unreal Engine are on there, but there are hundreds of game engines, not to mention proprietary game engines. Basically, nowadays, most people who are making games are using a game engine, and each game engine will have their own pros and cons, strengths and weaknesses, pricing, of course. That's another. There's also graphics specific engines, which only really focus on rendering graphics, and you can integrate that with your game or your game engine, however you see fit. So the purpose of game engines, though, is to provide extensibility to games and allow developers to um, basically specialize and adapt their products using core functionality provided by the game engine to sort of streamline the game development process, as opposed to, for example, creating a physics engine every single time. I don't know how many of you have delved into physics, but that could get very pricey, very mathy, and just creates an additional barrier to games and additional time constraint. But the game engine industry as a whole, similar to games, the game industry has risen. The game industry nowadays is multi-billion-dollar worldwide industry. However, the game engine industry is also multi-million-dollar worldwide industry. So these two have a symbiotic relationship in terms of success in the industry. So I've talked a lot about game engine, but what exactly is a game engine? So for those of you software developers or potential software developers out there, you can think of a game engine as a game IDE. Actually, a lot of people quote it as a game IDE. Basically, it's a software framework that's primarily designed for the development of video games. Now, game engines provide developers with features right out of the box, such as 2D graphics, 3D graphics, physics, collision, audio, artificial intelligence functions. Once again, like I said, this reduces the time, complexity, and money needed to bring a game to market, allowing users, maybe such as myself or a very small team, to be able to create a fully functioning, good-looking game, a relatively realistic amount of time. Now, Unity, of course, is a game engine, so it provides a lot of the basic core functionalities, such as 2D, 3D graphics, physics, and support for virtual reality, augmented reality, PC, Xbox, so on. But another one of the big features of Unity is what's called the asset store. So what an asset is essentially is, let's say you're building a game and you're very good at programming, you got all the storyboard, you got everything set up, but you've never touched modeling before. You don't know how to create some sort of image and be able to animate that image. That's where the asset store comes in. Now you can buy from the Unity community pre-built assets that you can just drop and play directly into your Unity game. You can, of course, learn how to do all yourself, but if you won't want to, once again, Unity is providing these things for you, and you can simply just purchase, download, and apply to the game, and boom, there you got an enemy, you got bullets, you got a gun, whatever you can download off the asset store. And once again, so who uses Unity nowadays? I've said a lot about Unity, but realistically, who uses Unity? And as you can see, there's a lot of companies on here that you may not have thought, oh, that's a game company. And yeah, so I do want to highlight that, especially in today's modern version of Unity, it has a lot of capabilities and functionality beyond the traditional game engine sense. Now, Alphabet, parent company of Google, and also parent company of their AI company, DeepMind, I'm sure if you heard of it, they use Unity to train machine learning models. And Samsung, they have a whole slew of VR content for the Samsung Gear VR, not all game related, but they use Unity for over 90% of their content. Facebook as well does have a game room environment, so they do utilize Unity for more so the game aspect. And HoloLens, Microsoft augmented reality product, they also use Unity to craft augmented reality experiences, so to speak. And one thing interesting I found that I really did not expect was Disney is a frequent user of Unity. For example, in 2019, they used Unity to create backgrounds for The Lion King. They also use Unity to use for training purposes, and just creating any type of marketing. You can also work with Unity as well. Anything that involves creating an online graphical environment, whether it be games or not games, as of now, you can use Unity, and these companies take advantage of that. As of right now, Unity has stated that it is being used, or it was used to create, excuse me, more than 50% of all mobile games in the world right now, which if you could think about how many mobile games are in the market of the world, half or a little over half of them were used by Unity. Also, 60% of all virtual reality experiences, whether it be game or non-game, also were created using Unity. Now, a few popular games that you may know that actually do almost fully use Unity, Pokemon Go. It was a sensation a few years ago, but yeah, that was created completely in Unity, as well as the popular VR game Beat Saber and the Blizzard game Hearthstone and Call of Duty Mobile. These are just a few examples, but some notable examples, just to show you that you can create industry level successful games using something that I downloaded in 10 minutes on my computer for free. And so I just want to go over the basic workflow right now of Unity. And this is, once again, like I said, very basic. As you can imagine, games, even with a game engine, do get a little bit complicated in terms of game design. There's all these different aspects to games. But in terms of Unity, let's say you have an idea in mind, very simple. I just want to create the most basic game and, jump around. So what am I going to do? Okay, so I'm going to open up Unity. I'm going to create a 2D, 3D project, and we're going to set up what we call a scene. So a scene is very important, and I'll show you in a little bit some examples, but that is basically where all the magic happens in Unity. It's where you have a hierarchy of what we call game objects. And these game objects are very similar to components in React. If you're familiar with modern front-end frameworks, they use a component-based architecture, except for components, they're called game objects. And they also can have state similar to modern front-end frameworks. But in addition, you can add other components and scripts to these game objects to provide, like collision detection, mesh rendering, how all these different additional components you can add, you do it directly to the game object. But the game object is basically the fundamental building block of your game in Unity. Everything in Unity is a game object, even the camera, the player, everything. So once you've created your game object, you've added the logic behind it, then you want, okay, I want this player to have something to render on the screen. Then you're going to assign the asset, assign a asset, excuse me, to the game objects, and then it'll show in Unity. So I know this is hard to kind of grasp. So what I'm going to do in the next couple slides here, I have a couple examples of just some basic workflow in Unity, how to set up a scene, and possibly add a script. But also I want take this time to say the following examples I have were created, recorded, and published on YouTube by one of my favorite content creators, Brackies. He's got a whole slew of game development tutorials, and if it's something you're interested in after this, I highly suggest you go check him out. But for example, let's go ahead and take a look at how he just quickly sets up a basic scene. So as you can see here, when you open it up, you get a very blank, very basic with almost nothing there. But as you can probably see, there's a lighting and a camera. And on the left-hand side, you can see right there, being camera, directional light. So that's where the hierarchy is. And this is basically where you create everything. And here we're just going to go ahead and create a brand new cube. This is a very simple cube. And as you can see on the right-hand side in the inspector column, they have transform, cube, box collider, mesh render. I know it's a little confusing, but right now you don't really need to know. Just know those are different aspects of this cube already preloaded. The transform specifically is on every single game object, and that just simply has to do with its position, its rotation, and its scale. And it's traditional to set it to 0, so you have everything coming to 1. Now, with Unity, you have two different views, so to speak. You have your game view and you have your scene. So your scene is kind of where you as a developer are going to do creation. You're going to adjust cameras. The game is the player view, or at least a preview of the player view. So you can have them side by side. You can actually see first person, what me as a player, what am I going to do? And of course, in this game object, I could do whatever I want with it. I could expand it, make it bigger. In this example, we're going to create this tiny cube, flatten it out, and there we go. We have ground. Very simple. So within maybe 30 seconds, we've already created a ground, so to speak, for our game. Now we're going to create a player. And in this example, once again, very basic, we're just going to have a player cube. And we want our player cube to be sitting on top of our thing. So there we go. And it's essentially we have a game. Now all we need to do is add rules or objectives or obstacles, however you need to do. Now, of course, once again, you wouldn't want to necessarily play with just a cube, but this is just to show you how things are sort of set up. And once again, if you can see on the left-hand side, the player is there. You can add things to it. In this example, he's going to add a material, which even in Unity, you don't simply just change the color. You have to add an additional component to the player. In this case, we're adding material. And that material, he's going to change the color. You can also change, transparency. You can change, UV set. So many different settings with each individual thing. And also, if we wanted, we could take this. Let's say we have a custom texture as well. You can add, and we've spent so much time creating this texture for this player or this enemy, and the other guy, I wanted to spawn additional enemies with similar things. I can reuse all of these components, including player, ground, however I want. I can reuse all of them in any future project or any future part of this game as well. Also, one thing we could do is we can, like I said, we could change the position of this. He's going to go ahead and lift it up there. And one thing he does here that's very important and very basic, and for most of it, is to add some basic physics. So once again, I was talking about physics earlier. So this is very important because right now you can see the cube is just suspended in space. And it probably bothers you a little bit because you're thinking if this was a game, the cube would fall, right? But that's because the cube is not a physical object yet. But he go ahead and adds what's called a rigid body. Now this is a very standard physics that just shows that, okay, this cube is a physical thing in this virtual space. And it should act like it, such as it has gravity to it. And also what happens if you drop the cube on flat, it's fine. But what if you rotate it on its corner? Now, if you can imagine the cube rotating on its corner dropping, what's it going to look like? You probably seen something similar in your head, but your image of that is probably based in real life physics. And so the player will probably also have that sort of expectation of things to work, depending on the type of game, of course. So this is a simple way. Now we can just add physics within 3 minutes to a game without having to calculate the force of the gravity, all this kind of things. I have now added physics and gravity and all these things to my game. And that was done on a fairly quick basis. Okay, next, one last thing here, or one last thing is adding scripts. So scripts is basically the functionality of each. Now, okay, now we have a player. Well, what can the player do? Right now, he's just a box sitting there. But what if I wanted to add movement, or I wanted to add basically anything I can think of, the actual, meat and potatoes of this player's brain, so to speak, is done via C# scripts. So Unity primarily uses C# as its coding language, and also it comes preloaded with, or not preloaded, excuse me, with the option to download Visual Studio as its primary IDE for coding. And I personally found it to be very good for using this, as it directly integrates with Unity. So all we have to do is, create the script, drag and drop, double click, and then Visual Studio pops up. Now, in this example, you're going to go ahead and see something that may be familiar to some, maybe not familiar to others, but this is basically, as you can see, it's a C# class, very similar to Java as well. But in this, we have two functions, the start function and the update function. Now, every script comes with the start or update function. And the start function, just like it sounds, runs once, and it happens only on initiation. The update is basically where most of your code is going to go. One thing I wanted to say about the update function, if you're working in this, is that update is called once per frame. Now, if you don't know anything about frame rates, just on a very basic level, your computer can render a certain frame per every second or X amount of frames per second, and that actually differs based off a lot of different factors, but mainly the, say, speed or power of the computer. And that can become a problem in certain things, especially like movement, but there are methods and best practices in place to normalize functions and update so that they can happen seamlessly across different computers. But that's a little bit outside the scope of this. I just wanted to let you know that is something that's very important to keep in mind. In this example, he's just going to go ahead and do a quick debug log, which is very similar to console log for those of you familiar with JavaScript. And of course, it wouldn't be a tutorial without the Hello World script. All we're going to do here is we're going to add this hello world, and it once again happens at the start, and we just want to double check, is the player, when the game's running, is it reading this script? And how do we check that? We go to the console and say, okay, there should be a hello world there. And if there is, then we know, our player has a script. And like I said, well, there we go. It's very basic. Of course, it doesn't actually help us in this game, but just to show how it's not that difficult. Like I said, he just created the script, moved it over, double clicked, and then you work from there. And as soon as you save and exit, it automatically runs based off whether you put in an update or start. All right, and taking this example here one step further, just very, very brief, just so I feel like I couldn't show it without the ending, is this is kind of it coming together. He created a game called Cubethon, but as you can see, this is very similar to it. He added a couple obstacles, some level text, and there we're off to the races, essentially. And this is still that same basic ground and the same basic cube with the red. Everything's exactly what you saw previously. But once again, this is just very just a quick example of how you can create a game in Unity. Just so once you log in, you kind of know where you're clicking around, so to speak. Okay, so now what? So once again, like I said, my purpose of this was really to, I would say, foster the curiosity of those of you that has it, and that if this is all interesting to you, or you've ever thought about game development, or maybe now you're like, oh, okay, it's not quite as bad as I thought. Maybe this is something I can do. I would highly recommend, my personal favorite, using YouTube and all the various content on there to go watch tutorials, play around, similar to learning any new thing. Sometimes you just need to kind of get out there and do things and fail and try again, add your ideas. There's also plenty of courses on Udemy and Coursera, and they actually have, via Unity's official website, learn.unity.com. So Unity, their ultimate goal, and you can find it in their mission statement, is to quote unquote democratize game development. And what that means is basically they want to make game development accessible to someone like me or someone like you, as opposed to a big game company like EA. Games are only created by 100 engineers working together for 2 years. No, no, no. This, depending on your scope of the game and depending on your concepts, you can pick this up, you can do all your own research, and you can figure out what you need to do to get these games up and running. Unity also provides a platform for monetizing those games directly from Unity. And they actually allow you to not only download the program for free and publish those games, but they do not charge any licensing if you make under $100,000 USD on that game. And they have a very similar pricing structure to, let's say, like Unreal Engine, like I mentioned earlier. However, they're, like I said, once again, more tailored towards the indie game developer, but not just for it, as we saw with the game examples, Pokemon Go and all those things. Now, when I began this boot camp, I just wanted to not say, like, I thought many of the topics, so to speak, that we're going to go to, like React, all of these were just such complicated, frameworks that I had never seen before, and I thought that it would require years of practice or understanding to do. But now that I've become to demystify all of that, I felt that maybe I could understand Unity a little bit more when I took a look. And in the research for this project, kind of dabbling around, I actually quite enjoyed it. I found similarities across frameworks. It seems like whether you're game dev or software dev, programmers like to think in a similar way in terms of organization, structure, just the logical flow of things. It all seems to work together in a beautiful symphony of things. And I think that this really could open the door for me, just as a hobby at least, just to kind of get around and play out there. So I hope that if you found any of this useful, you also could, play around, do what you need to do, just have fun with it. I think that similar to what the CEO of Unity Technologies said, he said, I think it's sad that most people are consumers of technology and not creators. The world's a better place when people know how to create, not just consume. And that's what we're trying to promote. And I really, really, really think this quote resonated with me, in that I have always been a consumer of technology. I've never even thought about creating. And now that I'm going to go on to creating different types of technology, all of this exciting, it opens up a world of possibility, not just software, not just web apps or anything, just anything I wanted to create. I think I can. I have the tools that Code Chrysalis taught me in order to find out what you need to do and get things done. And I hope that you guys were able to do as well. So thank you. That's my presentation. Have a good day.